Okay, so tonight we're going to talk about reactions in aqueous solutions. This is from section 9.3. The objectives for this section, we won't cover all of this tonight, but the first is to describe an aqueous solution. We've talked a little bit about that in class. To write a complete ionic and net ionic equation for chemical reactions in aqueous solutions. And we'll talk about what those vocab words mean. Complete ionic as well as net ionic equations. And we'll predict whether reactions in aqueous solutions will produce a precipitate, a water, or a gas. All right. The review vocabulary, just to remember, a solution is a uniform mixture that might contain solids, liquids, or gases. New vocabulary, please, you should have your notebook out, taking notes right now. If you do not, go get that. And add to your vocabulary list aqueous solution, solute, solvent, complete ionic equation, spectator ion, and net ionic equation. So pause the video right here if you need to get down all of these vocab words. The main idea for this whole section will be that double replacement reactions occur in aqueous solutions and produce precipitates, water, or gases. An aqueous solution contains one or more dissolved substances called solutes in the water. So our solvent will be the water, the solute will be whatever we put into it. So if we're making salt water, the solvent will be the water, it's an aqueous solution. The solute will be the sodium chloride, the salt that we put in there. The solvent is the most plentiful substance in a solution. So if we're making the salt water, we're obviously going to have a lot more water than we will salt. Water is always the solvent in an aqueous solution. Just by definition, if it's aqueous, it's got to be water-based. Remember the difference between if we have a liquid or if we have an aqueous solution? Aqueous always has to be water. Liquid could be something like bromine, which is liquid at room temp. There are many possible solutes. Sugar and alcohol are molecular compounds that exist as molecules in aqueous solutions. So whatever the solute is, there's too many to even count here what they would be. Sugar could be one. We can also add alcohol. For example, the isopropyl alcohol that you have probably in your medicine cabinets at home is a mixture of a stronger propanol alcohol mixed with water. Compounds that produce hydrogen ions in aqueous solutions are acids. So this goes back to the last chapter. It's going to make hydrogen ions. When you put it into an aqueous solution, then that makes it an acid. Ionic compounds can also be solutes in aqueous solutions. So we've talked about making ionic compounds. These can be solutes, like I said, with the sodium chloride. The sodium, which is a cation, put together with the chlorine, which is the anion, this ionic compound can also be a solute. When ionic compounds dissolve in water, their ions separate in a process called dissociation. So when you put that ionic compound into the water, you have dissociation happen. When two solutes that contain ions as solutes are combined, the ions might react. So two solutions that each contain ions as their solutes, then if you think about it, they're ions already, you might have a reaction there where they can come together. If they react, it's always a double replacement reaction. So just like with the posters that you guys made today that we talked about, you have double replacement. So you have the cation of one combining with the anion of the other and vice versa. Three products can form with reactions in aqueous solutions. You can have precipitates, which means that something is going to come out of it, a solid. You can have water, more water formed, or you can have a gas that's given off. Aqueous solutions of sodium hydroxide and copper 2 chloride react to form a precipitate of copper 2 hydroxide. So if you look at this reaction down here, okay, you have sodium hydroxide, which is aqueous, it's mixed in with water, with, again, a copper 2 chloride. All right, this is somewhat like the solution that you had on your test that was in the water. Okay, so aqueous. And when you put those together, we have a double replacement reaction where the sodium and the chlorine come together, so sodium and chlorine, and the copper and the hydroxide come together here. Okay, so double replacement reaction, but now we have a precipitate. We have a solid that comes out of that. Ionic equations that show all of the particles in a solution as they actually exist are called complete ionic equations. Okay, so a complete ionic equation is like this one here. Okay, so we take this equation and we actually break every little thing down. So you have here you have the sodium, and you have the hydroxide, and you have the copper, and you have the chlorine. And so every little thing is broken down, and now you show how many of each. If you notice here, there's a 2 here, and there's a 2 here, but this 2 also takes in the hydroxide, so we've had to put a 2 here. So it shows every little part. It is about as exact, not even exact, as specific and as minuscule as we can get in showing every tiny part of this reaction, okay? So if you have all of that, then that is known as a complete ionic equation. All right, ions that do not participate in a reaction are called spectator ions. Okay, and they are not usually written in ionic equations. So spectator ions do not participate in the reaction, and so therefore we do not write them in ionic equations. An example here, formulas that include only particles that participate in reactions are called net ionic equations. Okay, so the ones that only have the things that participate are here. So here we're going to have hydroxide plus copper gives you copper hydroxide. Yeah, this actually made copper 2 hydroxide. Okay? All right, so here's just a comparison, okay? This is the complete reaction like you would write if you were writing a double replacement. This is the complete ionic equation where you give just every tiny little part broken down as much as you can, okay? And this final net ionic equation is where you only write what's happening in that part. Okay? All right. We're going to stop there for today. Tomorrow in class we'll continue talking about all the different types of reactions, and you'll be going through figuring out what kind of products do you expect from them, depending on what kind of reactants you have. All right, so have a good night.